Hello, everyone. Um, Hope everyone is enjoying B-Sides SPL today. Today we'll be talking about SmartStore and you. And my name is Jared Seats. I have been doing Splunk stuff for like 8 to 9 years ish, give or take. I've known about Splunk for over a decade for sure. I did do a round or a few rounds or several rounds of Splunk professional services, and I've seen a lot of Splunk environments, big, small, and well run and not so well run, but trying to fix those. So I've been around the block a few times. I'm not as cool as the Fez people because they are amazing, but I like to consider myself pretty competent, and that's how we're going to roll. So this talk will be focused on SmartStore and a little introduction, little basic steps, and then my experience learning about SmartStore on like an oopsie that I've seen happen. And basically, this is a journey to basically tell you what not to do and to avoid that step. So let's get this ball on the road. First, one of my favorite slides is this slide, the forward-looking statements. Take everything that I say with a grain of salt, future-looking, Powerball numbers, all that fun stuff. Just keep in mind, this is just talk, technical talk, and I'm going to try to hopefully we all learn something at the end of it. So, one thing about this talk is going to be like, what is SmartStore? What's it leveraged for? Like, how do I want it? And like, going into at least one of the quirks that I found. There's a few, but the big one that I found was pretty interesting, and we'll be going over that later in this talk. What's not in this talk, this isn't going to be a step by step on how to set up SmartStore. There are probably other talks or even the Splunk docs, which are actually decent for what they are, telling you how to set it up. It's still very mind boggling, especially if you're not familiar with cloud technologies, which is what my experience was when I started up learning SmartStore. Most of my experiences with the Amazon S3, but SmartStore is supported by other technology as well, which I'll go into this next slide to say what exactly is SmartStore. I'm just going to read the slide for you. Index capability provides a way to use remote storage for Amazon S3, Google GCS, Google Cloud Storage, and then Microsoft Azure Blob Storage, which is my favorite name, Blob, because just a block of storage, which is just fantastic. And the SmartStore itself, and for a Splunk aspect, is this is where it stores index data. So this is data that's come in, it's been indexed, and now it lives on the SmartStore. We'll go deeper into the process of how it gets there later in this talk, but I guess the big deal is like, so who cares about this? I can set up a SAN in my data center. I have like my own indexers. I mean, they have spinning disks, they have SSDs. Why do I care about using a fancy cloud technology just to think about making my life easier, or is it really so much beneficial? We'll go into that just a tiny bit. It does help. I like it. I've There's definitely, like I said, quirks to SmartStore, and then it's just a learning process. Unfortunately, like everything with all technologies, so we'll have to keep that in mind while we're going through this process. So, some of the pluses for SmartStore, cost. If the SmartStore technology is set up appropriately, it can reduce your costs. Why is that? Well, just like the cloud, it can reduce your storage if it's set up properly, configured properly, and leveraged moderately well, and not having like creep of stuff come in. So, SmartStore is based on technology that's solely designed for storing items. So it's really, really good at storing items. And because it's a cloud, it's someone else's computer and it's someone else's problem. So if a disk goes out in the SmartStore, you don't have to deal with getting it replaced or hoping the RAID doesn't fail. In theory, the vendor of the cloud technology should be the ones managing that and taking care of that. And most of the big ones have a pretty, I'd say, a solid uptime for what they have, minus hiccups that do happen. But it's one of those trade-offs. Do you trust the vendor that has like experience doing this, or I mean, your shop may be better, and that's clearly possible. Um, Another benefit of SmartStore is just the way it works with the indexers, and again, we'll go on this later in this talk. But if you have what Splunk calls the cache system for SmartStore, it's a way to basically you're bringing in the index data, stores it onto like a local disk, which is normally SSDs, and then after they roll, they get shipped off. So setting up that cache correctly is critical, and it's also a caveat on like why that's one of the quirks that could lead to a downfall of not setting up SmartStore correctly. Not that I have experience with that. No, never set up caching correctly or too small and wondering why everything's going sideways. Again, I mentioned this before, the resiliency. So since the buckets get moved to a remote store for you, and this remote store is either by a vendor or it should be more resilient, or not more resilient, but very resilient to maybe how you're normally expecting stuff to work. So like if an indexer go down, if all your indexers go down, um, the data technically still lives there. Like even if every single indexer in the cluster goes down, the data still lives there. It's not erased, but can't be searched yet until you bring up more indexers. But we'll get into that later. So starting off with SmartStore, you're like, well, what's really the difference? How do I get started? Again, the Splunk docs are pretty good on this. I would read through them once, twice, thrice to really make sure you have your concepts kind of bolted down and you know what's kind of doing what for this. For the basics of the setup, indexes.conf, I know the index data for index stuff is actually in indexes.conf, and that's important for SmartStore. I mean, I would have never thought that, but hey, Splunk may have a plan. One of the big things is like the storage type is going to be remote because the way the indexers see SmartStore as a remote storage, which it is, makes sense. The path to the SmartStore, and then the endpoint, which is basically because it's not technically in, it's remote, so it needs to know where it needs to point to connect to the storage. The other big thing to remember for SmartStore is authenticating. I mean, we've all read in the news, bucket open to the public, blah, blah, blah. That's not likely to happen. I mean, all the vendors have really just like made that a no-no. But in the meantime, it's now like you have to know how to actually connect your systems to that SmartStore, and that may actually be the hardest part. The other thing is making sure like encryption setup, SSL, settings in the different settings for Splunk, the verify server cert, all that fun stuff, common name and check, just the standard SSL cert things. And that's just making sure that when you connect to the bucket, it's secure, it's locked down, and it's just the good way to do it. So moving on, there's a few other things to talk about SmartStore. One caveat is like if you have multiple clusters, each cluster really needs their own SmartStore. So you can do some shenanigans with like different paths and stuff, but it's recommended like if you have a cluster, they're separate. They should have their own like SmartStore storage, especially if they have multiple like the same indexes across different clusters. So if you have like a firewall index, you'll want to make sure the firewall index is in SmartStore, and if there's another cluster with firewall index, they have their own SmartStore. And like again, you can do some shenanigans, but to keep it simple, the way I've seen it done most of the time is like each cluster will get their own SmartStore, or each individual non-clustered indexer should get their own SmartStore path. So it's just to keep that easy. Another caveat with the rep factor, it has to be auto. No ifs, ands, or buts, just letting Splunk do its thing. Something else we'll get into later in this, but like max data size also has to equal auto, and 750 megs. So one caveat to that is like your buckets are going to be smallish, 750 megs. They're all going to be the same size. The reason why this is important is because you're moving data from your indexers to remote store, so SmartStore. And if it needs a bucket that's on SmartStore, it's not local, not in the cache, it has to pull it back. And you don't want to transfer massive files of buckets back and forth, where if you only needed like one tiny item from a bucket, just pulling back the 750 meg bucket is quicker than trying to pull back the 10 gig bucket. Um, on the caveat, you're going to have a ton of buckets moving back and forth. So Splunk has really improved that number from version 7 to, well, version 6 to 7 to 8 to 9, where that number is pretty astronomical, and it needs to be because you're dealing with so many buckets. And if you're streaming in tons of terabytes, petabytes of data, you're going to hit like those bucket limit counts before you can blink, because you can't do to reduce my buckets, I'm going to do, larger buckets, stuff like that. You have to keep auto 750 megs, and it's there for a reason. It's to make the efficiency of SmartStore. Um, Another thing is when you have data, you'll want to use a term called bootstrapping to the new indexers. And by when I mean new indexers, so if you have SmartStore data, you can actually lose all those indexers to bring new indexers to connect to it. You just bootstrap it. So if you need to like decom hardware for some reason, or you can't do like a quick conversion of the hardware in the cloud, where the indexer itself has to be completely destroyed and a brand new one has to be, you can just use a bootstrap process, and that indexer will actually adopt the SmartStore, and then it'll start acting like, hey, this is my data, it's been my data all the time. And we'll go into the naming convention on how it'll tell the buckets apart. One other thing is, don't forget about caching. Your cache is going to be your local disk. So for most of the setups I've seen, one favorite, I'll go into Amazon, is like the i3Ns. They've got a large amount of SSD cache, and you'll basically calculate how much local SSD cache versus how many days you want to be quick storage. So if you want to have like 30 days of quick searching, but you have to hold data for like 12 to 15 months for whatever reason, um, having your cache calculated based on, hey, I need to hold at least 30 days of data locally, and that way if they're searching in the next 30 days, I'm not exactly hitting the SmartStore every search. I'm only hitting the SmartStore like maybe if it's like at the end of the 30 days, because it's been rolled off, or evicted is the term. So keep that in mind when you're dealing with SmartStore. The cache is the caveat you can't forget and can sometimes be overlooked. Your cache should also be as fast as you can afford, which is always the case with indexers, but definitely important for this. So one scenario that is probably like, if you're new to SmartStore, like, well, how do I get my old data to the new storage? Again, Splunk Docs, they have a really good step-by-step instruction on how to do this. High level for this is you'll want to set up, like, they say set up single indexer, have your SmartStore set up, ready to receive data, upload small samples, see if you can read it, then upload data to the indexer and wait for it to roll to warm. And then once it rolls to warm, see if it actually shows up in the SmartStore. Then you can search, can you see it, remove the bucket, make sure it gets brought back into the indexer, stuff like that. Those kind of tests they outline step by step by step, which is super awesome. And it's essentially what I had to do when I was trying to learn SmartStore, was like literally, how does this work? So go to that. So once that's done, then it's like you have indexers running. Depending on if you're just going to like migrate them, you'll basically put, like, if you have clusters, put them in maintenance mode, shut them down, make sure all the configs are updated, server.conf, indexes.conf, and set up for basically, like, hey, I'm using SmartStore. Turn them back on, and then magic happens. It starts the migration process, and you can actually monitor, if you have your monitoring console set up, you can see what the percentages of like how much data is moving where, and how much more you have each indexer, like what percentage each indexer is using. So If you have 10 indexers, 9 of them are done, 90% done, such and so that way you can see how many indexers are still trying to process and upload data. And again, remember, if it's local to the cloud, it's uploading, and I mean, uploads are always the fastest thing in the world, so it may take a while depending on how much storage you're wanting to move from cluster local to cluster SmartStore. So that's just something to keep in mind as well. So this next slide is basically just something I stole from the Splunk website, but it's fantastic on describing how basically a SmartStore setup should be in a very high level sense. You have your the clustered indexers, search heads, all that fun stuff. So the data comes into an indexer. It gets written to disk locally, hot buckets, and gets written to disk. They're small buckets, so if data is coming in constantly, they'll roll to warm. When it rolls to warm, the bucket itself says, "Hey, I need to get kicked over to the SmartStore." So it'll actually take a copy of the bucket and it'll get kicked over to the SmartStore and be on the external storage. The indexer will keep the warm copy of the bucket on local cache. So this is why the cache is important. So data keeps coming in and buckets keep rolling, slowly filling up the cache. So when searches happen, searches will, like, the indexer will like, oh, I've got that locally. I'm just going to give you the results here. Or it's going to be like, I don't have that. That is actually on the SmartStore. So it's got to pull that bucket out, put it on disk, and says, okay, here you go. But now you're thinking, well, what if I'm at capacity? So, like, I have a terabyte of cache, and I am constantly getting data in, and I'm constantly searching data. What happens is the indexer will start to evict buckets. So if you're doing a search for 30 days and you have 30 days worth in the cache, it won't have to, like, evict additional buckets when you search. Because when you search, if you're searching like, oh, I need to search from a year ago, and you search and it's like, I don't have any of those buckets, I've got to bring those 10 buckets from SmartStore to cache, it's got to evict buckets technically prematurely to bring those old 10 buckets back. And so basically you're kicking buckets that are still within the 30-day window out, bring them back to the cache, and then they're read like normal. And then eventually they'll get kicked out back out based on, like, the process that Splunk has for, like, how recently was this searched and stuff like that. So whenever you're doing the cache management, checking, sizing, that's always something to keep in mind and to process on, like, how often will I need to search past this? Once in a while is fine. If it's constantly, maybe the cache needs to be bigger, or maybe that's just the way it goes. And obviously the searches will be slower because it's quicker to just read SSD on the thing versus having to, go to the SmartStore, download the buckets, kick out old buckets, stuff like that. So that's something to always keep in mind. You should also try to keep your cache, have a little headroom on the disk, I've noticed. I haven't seen this directly in the docs, maybe I skipped it, but I would always have a little headroom because, like, once your cache fills up, like, that's how much space it'll keep. So if you have a terabyte of disk and you say I have 900 gigs dedicated to cache, it will fill up that 900 gigs and then constantly keep it at 900 gigs closely as possible. You also don't want to accidentally fill up, like, opt, or you'll get alarms, or Splunk will stop working because of, reasons. So keep that in mind as well. So one thing that I've noticed in using SmartStore is leveraging DB Connect to manage and talk about the buckets. The docs go into this as well. Again, I'm going to mention them a lot because they're actually pretty good. Actually, they are good, so keep that in mind. It's a lot of information. So again, for, like, these specific scenarios, leverage docs. But when you're using DB Connect, one thing you have to keep in mind versus just normal usage is there's a cached argument, and they mention this. So if you have the cache equals false, it'll look at the local cache. So if you're looking at indexer 1 and it had a bucket, but it's evicted it because it's over 30 days and there's no space, your results will say that bucket is there, but it's 0. Doesn't take up any space. If you do true, it does the manifest. The manifest will tell you what's the size of the bucket on the SmartStore size. So it'll tell you exactly, like, oh, well, this is actually how large it is. That's one caveat that you definitely need to keep in mind, because it's tripped me up in the past when I'm trying to figure out, like, well, how much space am I using? What are these bucket sizes? Um, so making sure you always use the cache equals false if you're just looking on disk, because you may want to know, does this bucket actually live on this index, or am I going crazy? Or if you're actually wanting to find like the raw size of the bucket and like going to the actual SmartStore. Um, one leading up to that, another command to use with dbinspect is like the Splunk CMD RFS command. It's pretty phenomenal, and I love it. And it actually, like, going into the scenario later in this talk, will I think I've got a few of the example commands, but they using this to actually go and like reach out to the bucket, download a copy, or even like doing an ls. This kind of command can really help you troubleshoot, especially when you're going deep in the weeds of like trying to figure out what's going on with these buckets that are in SmartStore. um, so that's something else good. The monitoring console has pretty good cache performance dashboards, so it will tell you like how often you're evicting buckets, um, and like how often you have like failed cache misses, they're like people like to call it. And that would be like if you're doing a search, it doesn't have the bucket, it's got to reach out to SmartStore to pick up that bucket, and how often is that happening? If it's happening constantly, maybe you need to figure out like, are the users doing proper searches? Is someone doing improper searches, or is it just like it's audit season and they need this? So like that's something to always keep in mind when you're looking at stuff. um so now that you've heard all that on SmartStore, you're like, oh yeah, come on, let's do this. There's you convinced me. I want SmartStore. There's nothing that convinced me that SmartStore is not my future. And I mean, what could possibly go wrong? There's nothing. Like, end talk. Have a great, enjoy the rest of B-sides, all that fun stuff. Or if you're watching this as a recording in the future, hope the weather's great. And no, wait. All right, let's stop. Let's roll back a little bit. And there are a few. These are the quirks and differences you need to know about, especially when you're dealing with SmartStore. So, one thing, and this will be a big one in the future, the bucket pathing. The next slide, we're going to go into like how they're different, but I want to keep in your back of the mind. The caching. So leveraging the cache for S3 is something you'll want to keep in mind as well. Like, again, the cache is beneficial, but can also be detrimental. One thing to note is there are no cold buckets at all. Whenever a bucket gets hit, gets written to, read write, hot bucket. Then it rolls to warm. In a normal, or not normal, local storage, it would get rolled to cold and compress. That is not the case for SmartStore. SmartStore doesn't want to have to zip, unzip, unzip, zip, unzip, unzip. It's just a warm bucket, and that's what you get. There's no cold. So keep that in mind, because that will kind of be important with another thing that's coming up. You'll also need, for caveats, like the search factor, rep factor have to be equal. Not really a problem. Most people I know did like 2, 3 whenever they did like larger clusters, and that's just something to keep in mind. Small buckets, I kind of mentioned before, you can't have large buckets. It's all got to be the 750 meg auto. And then I'll dig into this a little bit. The monitoring console can be filled with misleading information for SmartStore. And what was happening that I see in the past, I haven't checked with 9. Well, I did, but it didn't look like it was fixed. Was that whenever you're doing a SmartStore and you go to like indexes, volumes, and settings, and it'll tell you how much disk space the index is taking up, I was noticing that the number was much larger than it should have been. So we're talking about, we were massive compared to, like, I go to the SmartStore, it's like it's only 1 terabyte, but I look at monitoring console, it's like, no, it's 3 terabytes. I don't know what you're talking about. So what I noticed for SmartStore is, one, it doesn't distinguish the storage between how many, the index storage on the SmartStore versus the storage on the indexers. But what it is doing is taking that index size and then multiplying it by your search factor rep factor. So if you have a search factor rep factor 3, that storage that's actually taking up, where it's only taking up 1 terabyte, is multiplied times 3. And that is actually what I've seen in my environment. Maybe it's a bug, maybe it's a quirk, but like it's made me like, you need to sanity check when you're seeing crazy different numbers than what you're supposed to be. And it looks like that the monitoring console wasn't completely, it doesn't take into SmartStore account fully, and maybe that's been updated for 9. But that's what I've noticed in the past. So hopefully someone can be like, you're wrong, please, this is not true. But that's what I've seen before, and that's what I've seen up to 8, the newest version of 8. So keep that in mind. Also, SmartStore, you need a cloud technology. It's remote storage. It doesn't have to be cloud. There is a few vendors, which I should have listed, but I just couldn't. Because I've heard mixed things. I've heard both good and bad things, so I just not going to go there. The other caveat that I've hit is there's no easy way to thaw data using SmartStore. In fact, it's not supported. Straight from the docs, you cannot thaw an archive bucket into a SmartStore index, even if the bucket, prior to freezing, was part of a SmartStore index. So if you have data that you are freezing because of reasons, you can't have that data brought back into that same SmartStore index. You have to set up a completely separate index, local disk. So if you're using an indexer and you have cache, and you're trying to use that same indexer, and you put that data on that disk, you might want to make sure that it doesn't affect your cache, and keep that in mind. It's almost to the point where you basically have to set up another indexer to take it, and put that data onto that separate indexer that only does local disk, and that way you're not mucking up your SmartStore settings with trying to bring back frozen data and then thawing it out. Now, you could go around this by using some software or another script or something and just re-ingesting it, like whatever. It's frozen, but I'm just going to re-ingest it and throw it in its own separate index on its own. I'll have this different retention set for it so it doesn't refreeze as soon as it goes in, and do that. But that's one caveat that really need to keep in mind, especially if a freezing to thawing is important to your prospect. Making sure you have a process in place to take care of that. So, next, let's go back to a breakdown between those buckets I mentioned before. So, on the top, local disk, good old-fashioned Splunk home, internal db underscore epoch 1. So you knew what one bucket was, the epoch 2. So youngest, oldest, oldest, youngest, an ID, and then the GUID of the indexer. Pretty straightforward, nice, works out pretty well. Hey, what could go wrong? SmartStore remote bucket path. Bucket ID number, dash origin GUID. Okay, that folder path. And then it's the GUID ID, uploader GUID, and bucket contents. Okay, I'm not really seeing a huge problem here yet. The bucket underscore ID underscore number. We'll get into that in the next place, so this is going to be talking about the scenario that we have. And the scenario we had was we were seeing data kept disappearing. So we would ingest the data, we'd search it, it was searchable, but then a few days later it would just be not searchable. And for this scenario, we actually have like a manifest. We know how many files should be in this event. So like we have file 1 and it should be 100 events. And it had 100 events when it came in, but then 2 days later it only has like 95, 90. And we're like, what's going on? And different files, different indexers, like, oh, what's the caveat? And like logged a ticket to support, and we started working with them, and we had to dig deep down. Dig deep down, because like it would happen occasionally, then it would happen for weeks, and we're like, oh, okay, maybe it's fixed, and we would just keep the ticket open. Then it would happen again. We get on a call support. We got super smart people finally come in, and like they came in, they brought in devs, and they stepped through processes. We did that RFS command, like we were listing buckets out. We're like, why does this bucket exist, stuff like that. And for us, the end result was a misconfiguration was found to be the culprit. So how? We learned how buckets were named differently. Remember how I told you it's not epoch, it's a little different? Well, we learned there's a bunch of .dat files in varlib Splunk that are critical in the bucket placing naming. I'll get into that in the next second. We made a symlink Splunk home varlib to our ephemeral drive. And for those of you that don't know, whenever you stop a cloud server, at least the ones we had set up with ephemeral, the ephemeral drive gets completely wiped out. So ephemeral drive gets wiped out. We're like, we don't care. The index data lives on SmartStore. Why do we care if we wipe out ephemeral where our cache is? That's fine. But if we review these buckets, hash bucket ID. So the bucket is the index name, the ID, and then the GUID of the indexer. So those DAT files set that number. The highlighted yellow number is those DAT files. That's all they are. They're just a number, like it'll say under internal.dat, and then you'll see a number. I think it starts with 0, and then it goes up. So we're like, okay. So what could happen? Oh, if we're getting rid of those DAT files inadvertently because we just symlinked our lib there, and they shouldn't have been, and they get reset back to 0. Oh, they get reset back to 0. Reset back to 0. So the only thing changing would be the ID on the bucket. So because we symlinked, those DAT files got wiped out. They start back at 0. So the new buckets would be underscore internal 0, the GUID ID of the same indexer that we just wiped out the data. But there's already a bucket there. So what happens is that bucket's like, unless you have versioning, it's going to be like, nope, I'm the bucket now. And we were just wiping out our old buckets. And what was happening is we were having to reboot indexers because of, like, Amazon says there's an issue with them. They need to go in maintenance. Please shut them down. Start up a new one. Everything's fine except for ephemeral gets wiped out. And when ephemeral gets wiped out, the dot files got wiped out because we had that symlink there. So the same buckets would wipe out the old buckets, and it would only happen when we restart index because it has the same GUID, and it would start by 0. So all the buckets from 0 to whatever number it was would get wiped out, and then restart when the indexer gets stopped and start again. So that's why it was random, because we'd go like weeks without any problems, and then Amazon would be like, oh yeah, these indexers need maintenance, or there's like a patch update, we just need to shut down the indexer for whatever reason. It's not common, but like, whoops. So what we did to fix it, we removed that symlink because you shouldn't need the symlink, and we just set up, Splunk DB as the opt ephemeral instead of symlinking it like we should have done. But that way the .dat files live on our permanent /opt, which is EBS, and not going anywhere when opt ephemeral dies. So the .dat files continue on. What we ended up having to do is we created artificial .dat files with like large numbers. So once we restart them again, it would start with high number, and then we just live our merry way and make sure we don't wipe out other buckets in the process of doing that. So it was a fun learning experience, and like support was phenomenal. And like we had, I think, every single SmartStore person like, what is going on? And it was such a head scratcher. So that's why this talk exists, because of this, and then everything else just get added on to fill this up to this point. But again, SmartStore is awesome. It's a great way to store data. It works really well, but there's definitely some new features that are learning experiences and should always keep in mind. Also, I did not submit these slides late, even though I might have, but as you know, talk is never late, nor is it early. It's here when it means to be. Thanks, and we'll be doing questions, and I think that is all. Take care, everyone. Hope you're enjoying the rest of the B-sides, and If this is from people in the future, watch all the other B-sides videos because I'm sure they're pretty much all amazing because they have to be. That's a requirement. All right. Thanks, everyone. Take care.